All right, so if we take a look at this problem. All right, guys, let's cut back into the chat. You have a question?
Yeah, I have a question.
What's that?
Prime numbers are the building blocks or elements of all whole numbers 2 or greater. Okay? So notice 243 breaks down into 3 times 3 times 3 times 3 times 3. So then when after Dorian listed all the prime factors, because the square root, we circle pairs of 3s, and there's 1 3 that's left over, you look right here. This guy's left over, and that's why he is stuck underneath the radical. But we could take out a 3. That's why he circled 2 of them, so you could take them out. Because underneath the radical, it's a square root of 9. Outside the radical, that's 3, because the square root of 9 is 3. So this is how you can simplify any sort of radical like this by prime factorization. I'll put that. It's called prime factorization. All right. So it looks like most of you got or understood what the quiz was about and how to factor those problems on the quiz yesterday. So today we're just going to extend that application into finding or solving quadratic equations or finding the zeros of a function which has the same meaning. You spoke. Let's resume here. Okay. All right. So let's take a look at on page 100, which if you don't have your textbook, I do have copies of it. So let me go ahead and hand that out now. Oh, no, I forgot to do my thing. Okay, so this is very similar looking to the problems that you had on the quiz. If you look at the right-hand side, it's a quadratic. So how would we go about factoring this on the right-hand side? Yeah. How would we go about factoring this? AC method? Okay, you could do AC method. Okay. Okay, so you want to go ahead and do AC method? Okay, so we do AC method, what's 1 times 9? Okay, and then what is the question? Factors of 9 that add to 6. And what would that be? 3. Now this is short AC because this is a 1. So you can go right to here. You cannot do this if it's not a 1 for the A coefficient. Yes?
We're solving for x.
Yes, solving for x. Yeah. So we have 0 equals x plus 3 times x plus 3. I recommend you guys check this, maybe FOIL it to make sure you did it right. You FOIL this, x squared plus 3x plus 3x plus 9. 3x and 3x makes 6x as a sum. So you know you did it right. So now what would the solutions of this be? What do you think, Caleb? X equals -3? All right, so if I plug in -3 for x, it should make this a true statement. All right, so if I plug in -3, -3 plus 3 is 0. 0 times, which happens to be 0, but it didn't have to be. 0 times anything is 0, so yes. -3 is definitely a solution. That's the only solution to this. Good says yeah, yes, you say yeah, you say yes. It is because this is the fully factored form. They happen to be repeating, so this is that multiplicity of 2 that you're going to hear about. So you didn't have to do both, but yeah, they're definitely, of course, x is equal to -3. They're the same. They happen to be the same factor. The linear factor to x plus 3. So notice this is just like the quiz. Can we please hold back on the calculator smacking the desk every 5 seconds, please? Jesus. Okay, so I factor this, and so I get x equals -3. Because the zero product property says that anything times 0 is 0. This is the whole reason we set these equal to 0. Is because we say, okay, this can be 0 or this can be 0. So we get x equals -3. And if we test it, like we just did, now really you want to plug into the original. 9 plus -18 is -9, -9 plus 9 is 0, so it definitely satisfies it. Over here I did tic-tac-toe method, where I write, this is A, this is C, this is AC. I think I may have gone with brief with you guys. You can use short AC method, you can use tic-tac-toe, whichever one you want to use, but A, C, AC, and then right down here, I write that B is 6. Okay, they have to add to 6, but they have to multiply to 9. Once that's filled in, now these can only be, certain values. Factors of 3. I would not write the 3 here because that's not a factor of 1. So it's got to work both this direction, going across, and the direction going up, where we have these purple ellipses, where we circled, this and this. Okay, so today, we're going to talk about how to solve quadratic equations. Some of you may have already studied this, you may already know, may feel like a refresher or a review for you. So we're not going to spend a lot of time on these methods, especially because most of you seem to understand how to factor quadratics. So to solve quadratic equations, the first step is to make sure it's in this form, ax squared plus bx plus c equals 0. Okay, so make sure it's set equal to 0 first. So here's an example of one that is set equal to 0. This is an example on the right. Number 2, factor out the GCF. What does GCF stand for, Don? Beautiful. Greatest common factor. Example here, 2x squared minus 4x plus 8 equals 0. The greatest common factor, what's the greatest factor they all three have in common? Is a 2. They all have a 2 in common. Factor that out, you would be left with x squared minus 2x plus 4 equals 0. Step 3, solve by factoring using AC method or tic-tac-toe method. So when you're focused on factoring, let's say just this guy, this is just a 2, that's a constant. So if you try to factor this, now this is short AC, right? This is a 1, so all I have to do is look at this and say, okay, 4. Factors of 4 that add -2. Are there any integer factors that work like that? Factors of 4 that add to -2. They'd have to both be negative, right? Because they have to make a product that's positive, but a sum that's negative. They both have to be negative, okay? So -1 and -4 would make what, -5 as a sum, and -2 and -2 would make -4 as a sum. So this guy here is prime, or not factorable to be prime. So in order for me to solve this, I would have to use the quadratic formula. Okay, it's not factorable. Okay, but again, step 3, what we'll be focused on today is solve by factoring using AC method or tic-tac-toe, whichever you're most comfortable with. I don't care which. And then number 4, if it is prime, or if you forget how to factor, let's say you just got to solve a quadratic. It doesn't say, hey, you got to solve this by factoring. Or even if it does, and you say, well, I want to get some credit. I forgot how to factor, but I want to get some credit. I know I can solve it using the quadratic formula. You can always use the quadratic formula. So the quadratic formula solves any quadratic. Does anyone remember the quadratic formula? I'm curious. And have it memorized, which you're going to have it memorized. Actually, I take that back. It will be provided on the EOC. So I will provide that as a part of like your reference sheet. But does anyone know it? Yes, just curious.
If it's negative b plus or minus the square root of b squared minus 2ac divided by 2.
Very close. Very close. The one little part was wrong. It's actually when you said the minus, it's minus 4ac. Everything else is correct. So that's when you have, so it's this, we have, when we have this, and then x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. And we'll be using this more when we have, again, we cannot factor. But we're looking at problems right now that's just, ones that do factor. So we looked at number 27 on page 100. And we saw that as an example. And that was short AC, right? It was just a quick one because this is a 1. So I didn't really have to do tic-tac-toe. I could have gone right to here. Let's look at another one.
Do you remember what number 4 said? The quadratic is prime, or should they have a factor? What was the last?
Use the quadratic formula.
Thank you.
Yep. All right, so this is number 29. It says x squared minus 8x equals negative 12. So Jasmine, what would be our first step? Jasmine? I can't hear what you're saying. Can't understand you. Can you please put your hand up? Okay. Honesty, I guess. All right, what are you working on there? Okay. Try to focus here. So, what do you think would be the first step? I'm asking Jasmine. You're right. You do know it. Make it equal to 0. How do we do that? You do what? Okay, what's negative 12 minus 12? Yeah, what's negative 12 minus 12? Negative 24, okay. Alright, so maybe not subtract 12. Add 12 on both sides. Good. So we add 12 on each side. And now we have this. Alright, add 12 on each side. So now we have x squared minus 8x plus 12 equals 0. And then now from here, just like your quiz, if I can factor this, I'll go ahead and do that. Now again, it happens to be a 1 in the front, so it's a quick one. It's a short AC. Alright, I don't have to necessarily do tic-tac-toe. You can. I don't have to do long AC, but you could. But because it's a 1 in the front, this one's very quick. What factors of 12 adds a negative 8? Negative 2 and negative 6, good. There we are. X minus 6 times x minus 2 equals 0. Again, we're only allowed to do this because this is a 1. I can't emphasize it enough. I saw a lot of students where it wasn't a equals 1, it was something else, and they want to jump right to here, and you can't do that. But you can for this one. Yes? Okay, good question. If we have time, I'll definitely look at it. So the homework is on page 131, 33, and 47 through 53 odds on the homework schedule on the whiteboard. And you're asking a question about which one? Okay. All right. All right, so there's 31. So 31 starts off like this. Let's see if I can get some ideas from you guys. Ms. Scarberry, what do you think? You look at this, and if you have this, did you have to write this down the steps to do these? Okay. Do you remember what the first step was? Okay. All right, then let me ask you, what do you think about this one? Is there a greatest common factor? Let me ask you that.
Yes.
What is it?
Yeah.
All right, that was one of the steps. The first step was to make sure that it's set equal to 0. The second step was to, if you can, factor out a greatest common factor. Always do that if you can. It makes it more simple. Now, if you do that with this, she said n, that's correct. You factor out an n. If you factor out an n, you're left with n minus 6. Okay? Now, just so you guys are aware, this is a quadratic where the c is what? C is 0, right? Ax squared plus bx plus c. C is 0. Or in this particular instance, an squared plus bn plus c. C is 0. You could write this out. You know, you could do this. You could say, oh, okay, n squared minus 6n plus 0 equals 0. And if you want to do short AC method, you go ahead and do that. There's nothing wrong with this. It's technically true. You could do tic-tac-toe or short AC, and you'd have the same situation that you have here.
How factor if it's 0? Nothing.
Okay, so I'll actually do, let me finish this, and I'll do tic-tac-toe and show you we'll get the same thing. So we're here. Now that we're here, what do you think, Marie, what do you think about this? Maria? I'm so sorry, Macy. Richard, yes? Okay, what do you think about this here? Do you know what n is now? If I say this times this equals 0. If I say this times this equals 0, could either one of them be 0? Do they both have to be 0 at the same time? Like, does this have to be 0 and this have to be 0, what's in parentheses here, at the same time for this to be true? No, it's true. Right? You're right. Not necessarily. They don't have to both be 0. So, this could be 0, right? Or this could be 0. So if you wrote that, you're saying this could be 0, or this could be 0. N minus 6 could equal 0.
So n can have different values?
Yeah, we could have up to 2 different solutions for this because it's a quadratic. Because it's a second degree polynomial equation, it's a second degree, the highest degree is 2, you can have up to 2 different solutions. Okay, so we got 1 here, the other one we said equal to 0, add 6 to each side, n equals 6. Can I write anything down? Oh, yeah, take notes, you may not remember it. So I'm now going to do this. Let's go ahead and take care of this if we do tic-tac-toe. All right, so we're here. So I wanted to say, okay, you think you asked David how to do this if we want to do tic-tac-toe?
That's what, yeah.
You started?
No, I asked, no, not, I was asking if you.
Someone wanted to see tic-tac-toe.
I do.
Yes.
Well, now I do.
Yeah, okay, so all right, so let's do it. Let's just do it. Who cares? I know someone did. Okay, so tic-tac-toe. A, C, A, C. Air conditioning. Okay, so what is A? A is 1, and what is C? 0. 1 times 0? 0. Okay, now what is B? I got -6 and 0.
B is -6. Yeah.
B is -6. Okay, we'll go ahead and box this guy down here. So this is B, okay? All right, so it's the same process. Factors of 0 that add to -6. -6 and 0, okay? Probably it doesn't matter where I write them. But now that I'm here, okay, now, oh what? So it doesn't matter how I write them. Now that they're locked in, now looking at these rows, okay, so I need to put factors of -6 here. and they have to also be factors of these guys above them. Okay, so, but it's got to be a factor of 1, whichever I list here. So if I did, for example, -2 and 3, or 2 and -3, there's no way I could do that because neither 3 or 2 or plus or, it has to be 1, right? It has to be 1 and -6, right? 1 and -6. So going across this way, 1 and -6. Okay. Now going up, what would have to go here? 0 would have to go here, and then it have to be 1 because 1 times 1 is 1.
Yeah.
Right? Now notice if I circle this like I'm supposed to, crisscross, it would become this right here. N plus 0, which is just n, and n minus 6, which is right here. So it works out the same exact way. So as long as it's factorable, you can use tic-tac-toe. Even if the C is 0, yes.
So if you just go, if you go like the n is square, you just go n times n minus 6. You don't have to do tic-tac-toe because that's basically what it is.
Oh, for this one here? When we first did it?
Yeah, is that the same step? Kind of just tic-tac-toe is a little longer.
No, these are actually very different. This one here, because we noticed, okay, there was a greatest common factor. That was n. I factored that out. And then you're already there. This tic-tac-toe is just the same process over every single time. A, C, put the B down there, da, 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 da.
You don't have to do that if you take out the greatest common.
This is why the second step, before you even going into trying to factor, is always factor out the greatest common
Oh,
factor.
so you always have to
Always do that. It makes it more simple. It makes it, not as big. For example, here, even though it ended up being prime, this was easier to look at and deal with than this was. So we factored out a 2. That's why we did that.
So why do they do the tic-tac-toe to just
Tic-tac-toe allows you to factor any quadratic that is factorable. It's just one method. You don't have to do it for this one. But I'm just demonstrating that you could in case you didn't recognize this. There's nothing wrong with doing this. Okay, but I would say definitely the step number 2 is to factor out the GCF first before you try to factor it using AC or tic-tac-toe. Okay? So that's number 31. So your homework you have written here, but it's written on the homework schedule. So for those of you that are comfortable with this and you want to just go ahead and start working on your homework, please feel free to go ahead and start doing that. If you're not comfortable, then please keep paying attention because we'll be looking at some more examples. Yes. Your hand raised. Understand the next section. I want you to understand that zeros has the same meaning as solutions, which also has the same meaning as roots. So let's get familiar with these terms right now. Roots, solutions, zeros. Okay? So if I have a function that's written, so say for example, 47. 47 says g of x is equal to x squared plus 6x plus 8. So this is a function g, or we call it g of x to be more specific. Yes? Deep parentheses? Okay, so this is a notation thing. This does not mean g times x. Oh, the quotes? That's what they're the names. So it's called zeros or solutions or roots. So 47, I have this function g, where x is the independent variable. It's saying, okay, x is my input. You input some value into x, and I will give you some output. So g of x is the output, right? So g of x, this is the output, and x is the input. What's wrong? You have pain in your shirt? All right, so if we're gonna, the directions say to find the zeros of the function, find the zeros of the function, find where the value of the function is 0, would I plug in 0 for g of x or plug in 0 for x? G of x. That's right. That is right. G of x, because g of x is the value of the function. X is just the input. This is saying, hey, I am a function of x. This does not mean g times x. This means I am a function of x. I am a function g where you specify some value for x, I'll tell you what the output is. So if we want to find the zeros of this function, we say, okay, let g of x be 0, so 0 is equal to x squared plus 6x plus 8. And then now we're back to just the previous set of problems. Just make sure you, before you blurt out, please raise your hand. So we let 0 be g of x. We said, again, find the zeros of the function. Find where this function equals 0. So now we recognize this. This should look very familiar. Is this factorable? Can we go right to here? Or do we have to do long AC? Can we do short AC? Why can we do short AC, Duke? Good, because this coefficient is 1, right? It's not written, it's understood to be 1. So we can go right to here. So we know it's going to be x, factors of 8 that add to 6, 4 and 2, very good. So now you're here. So now 0 equals this times this. Now I can just say this could be 0 or this could be 0. So x plus 2 could equal 0, or x plus 4 could equal 0. All right, solving for each one. Minus 2, x could equal negative 2. Subtracting 4 from each side, x could equal negative 4. There are the two solutions. And how could you check them? Plug it in. If I let x be negative 2, well, okay, so now we're checking. I let x be negative 2, so g of negative 2 would be equal to 4 plus 6 times negative 2 plus 8, which is equal to negative 8 plus 8, which does equal 0. So this checks off. That one works. That is definitely a 0 of the function. And then now if you tested negative 4, g of negative 4 would be equal to 16 plus 6 times negative 4 plus 8. 16 plus negative 24 is negative 8. Negative 8 plus 8 is 0. So that also checks off. So these are correct solutions to this quadratic function. So these are just like the previous set of problems. So to solve 47 through 54, make sure you let the function equal 0. Okay? For your exit ticket today, no offshoots or anything like that. Let's look at, I want you to do number 28 on your own separate sheet of paper. Make sure your name, date, and period are at the top of the paper.